Hello guys, I hope you will be fine. This is third video on the introduction of software engineering, and in this video we will start from project management. So this is a helicopter view of the whole chapter of the book, chapter wise chapter. So starting from project management. So in this chapter we will discuss management activities, project planning, project scheduling, and risk management. So first is management activities. So one is proposal writing, project planning and scheduling, project cost, project monitoring and reviews, personnel selection and evaluation, report writing and presentations. This is everything comes under management activities. So this is all about project management, and different plans are there: quality plan, validation plan, configuration management plan, maintenance plan, and staff development plan. So this is comes under management planning, management activities. And then there is a project planning. So if we talk about project planning, so here is some coding value: how we establish a project constraints and make initial assessment of project parameters, define project milestone and deliverable. While project has not completed or cancelled, loop, drop project schedule, initiate activities according to schedule, wait for a while, review project progress, revise estimates of project parameters, update the project schedule, renegotiate project constraints and deliverable. If problem arise, then initiate technical review and possible revision, and if and loop. So this is some coding version of project plan. The project plan, there are 7 major components sections. One is introduction, project organization, risk analysis, hardware and software resources, resource requirement, work breakdown, project schedule, monitoring and reporting mechanism, and then milestone and deliverables, which is also come project planning. So there is number of activities, and against each activity there are some milestone. For example, if there are requirement analysis, then the milestone will be the requirement definitions, and prototype development, evaluation report. For design study there is architecture design, and requirement specification there are system requirements. So these are the activities and uh, expected milestones. Then project scheduling comes, and we can see there is a figure for project scheduling. The number starts from software requirement, identify activities, dependency, estimate resources for activities, allocate people of activity to activities, create a project charts, and then activity chart and bar charts. And if there is something concerned, then we have to go back to estimate resources for activities. These are bars, charts, and activity network. Task duration and dependency. There is T1 duration 8 day, dependency on and then dependency. And we can see there is a 12 tasks and their expected duration, and then there is a dependency. So task 3 have dependency on task 1. So task 3 cannot be complete without completion of task 1, whereas task 5 has dependency on task number 2 and task number 4. So these are the task duration and dependency. By the way, this is very interesting thing. We will discuss this in charts as well, how we can use bars to identify the dependency and their durations. Well, there is activity and activity network. Let me tell you that in this chart what is M stand for. M is milestone 1. So if T1 completed means we have completed milestone 1, which we will use in task number 3. So milestone is considered to those tasks which has some kind of requisition for another task. So an activity network, so it starts from 4th of July 2003, and there's task 1, task 2 and task 4 will concurrently be started. We can't start task number 3 because task 3 has dependency on task 1. So 3 tasks are initiated concurrently: task 1, task 2 and task 4. Task 1 have 8 days to complete, task 2 has 15 days to complete, and task 4 has 10 days to complete. Once after 8 days, when the task 1 is completed, we can start this is a milestone 1. So after 8 days, 4 and 8, almost 12 days, we can have milestone 1. And once milestone 1 is completed on 14th of July, we can start task number 3. And milestone 1 also need to initiate task 7, as we can see in this table. So here is the activity network, and then we will finish it. And you can take a time to observe this chart as well. So moving on, yes, there is a chart, activity chart, which I was talking about. Here is a task 2, task 4, task 1 and task 2 are started on 4th of 7th. And milestone 1 is considered as when we will complete task number 1. And once the task number 1 completed, task number 7 and 3 can be started. And on 15th of August, we completed task number 4, and then at the same time we started task number 7, 3, and there is a milestone number 5. So there is a activity bar charts depend on the number of tasks and milestones. So these charts are called Gantt charts. Staff allocation versus time charts. This is also a kind of chart. Like Fred is working on task number 4, Jane is working on task number 1, Annie is working on task number 2, Jim is working on task number 7, Mary is working on task number 5. So staff allocation versus time charts. So that's why one of the very important thing in project management is defining the time duration against each task. Then we have to look risk management. So there is 3 of major categories of risk, like project risks, product risks and business risks. So stock turnover, management change, hardware unavailability, requirement change, specification delays, size underestimate, case tool under performance, technology change and product competition. These are some types of risk and their types and descriptions. Here we have figure 5.10, and this is the risk management process. So number 1, we have to identify the risk and then list the potential risk. Then we will go to risk analysis and prioritize risk list. Then risk planning, and we will go through how we can avoid the risk and contingency plan. And after planning, there is a risk monitoring and risk assessment. And if we monitor the risk, we might have go back to risk analysis. There are four major stages: risk identification, analysis. There is a possible list. When we are analyzing the risk, there are different types like technological, people, organizational, tools, requirement, and estimation. Risk planning is also important thing, because when we have risk analysis, then we have to look after the risk planning as well. As we can see how we do this thing, like we need to plan to minimize the risks. So how we will plan our risk? So we have to identify the vulnerability of risk. So there are multiple risks, and then we will find its probability and its effects. Either is serious or tolerable or insignificant. And then we have risk management strategies. So there are a number of risk management strategies against each kind of risk. For example, if the staff illness, then what will be the strategy? Reorganize team so that there is more overlap of work and people therefore understand each other's jobs. Then risk monitoring, technology, people, organization, tools, requirement, and estimation are major risk types. So we completed chapter number 5. There is further video readings and some of the examples. There is very important question as well. Using reported instances of project problem in literature, risk management difficulties that occur in these field programming projects. One suggests you start with Brock's book as suggested in further readings. And then 5.9, in addition to the risks shown in figure 5.11, identify 6 other possible risks that could arise in software projects. So we have to make a chart, and then we will automatically understand where are some major lags and where the milestones are getting delayed. Yes, and there is a new part, requirements. So in requirement part, we will start from software requirements. So in this chapter, we will go through functional and non-functional requirement, user requirement, system requirement, interface specification, the software requirement document. Okay, moving on. Functional and non-functional requirement are given. Number one, user requirement and system requirement. So functional and non-functional requirement is separate thing, and user requirement and system requirement are something different. In user requirement, there are client managers, system end user, client engineers, contractor managers, system architectures. Whereas in system requirement, there are system end user, client engineer, system architect, software developers. So these comes under non-functional requirement. And third is domain requirement. So functional requirements, there are three major uh, stages or types of this functional requirement, and then there is a non-functional requirement. There is a huge hierarchical types of non-functional requirements: product requirement, organization requirement, external requirement, ethical requirement, sorry, usability requirement, delivery requirement. These are also comes under non-functional requirement. Everything that is not expected to a particular system are called non-functional requirement. And then there is a matrices for specifying non-functional requirement. So speed, size, ease of use, reliability, robustness, portability, these are the major requirements. And then there are system requirements, user requirements, system requirements are further explained in figure 6.11, negotiation for requirement specification. Structured natural language, these are the notation, sorry, not for negotiation. Design description language, graphical notation, and mathematical notations. And there is a case study for insulin pump control system, like how it works, and before making that system, what were the software requirements. So these are comes under the system requirements. So tabular specification of computation, sugar level falling, and these are different kind of programming requirement which is part of software requirements. And ATM withdrawal, sequence diagram of ATM withdrawal, how this system work, and before making the system, what are the software requirements. Then there are interface requirements, then software requirement document, which is also very important part. One is system customer for managers, for system engineers, system test engineers, system maintenance engineers. These are type of documents. So the IEEE standard suggests the following structure requirement document, in which like there is an introduction, general description, specific requirement, appendix, and indexing. The structure of a requirement document. So there must be a following chapter like preface, introduction, glossary, user requirement definition, system architecture, requirement specification, system model, system evolution, appendix, and indexes. And here we go to the exercise. And in next video we will start covering requirement engineering process. So thanks for watching. We will come in next video. Bless you.